Hello, everyone. Welcome, and thank you for joining us today for our Temporal Cloud Observability Intro to Tuning Workers with Metrics webinar. My name is Melina Valentine. I work on the marketing team here at Temporal. So now I'm excited to introduce you to our speaker, Mike Nichols. Mike has worked for 17 years in software engineering in various leadership and developer roles. He has extensive experience up and down the application stack and has delivered products in large and small organizations across a variety of problem domains. He's led engineering teams using temporal services to speed product success with its powerful approach to meet real-world application requirements. And now he applies that empathy for developers, architects, and product leadership into solutions for temporal customers as a principal solutions architect. So we're excited to have you joining the conversation today. Thank you again for joining, and a friendly reminder to submit your questions using the Q&A button at the bottom at any time. With that, I'll hand it over to you, Mike.
Great. Thank you, Melina. It's a privilege being with everybody today talking about this important topic. So today we're going to be going over temporal cloud observability and start dipping our toes into how do you tune workers with using the metrics from SDK, cloud, and so on. This is an introductory session, and so I'm keeping things at a pretty high level. And so there's very few prerequisites. Somebody already asked about prerequisites for this session. Even if you're beginning with Temporal, you should find this helpful to kind of understand conceptually what's going on inside of your temporal workers. Can y'all see my screen? Okay. Just want to make sure before
Yes, we can.
Okay, thank you. Okay, so before I dive into this topic, I wanted to just say a big thank you to everybody at Temporal that has put together all of these resources that I'm just pulling these things together. I'm learning this topic along with everybody else. So our dev success team has worked tirelessly to put out some great resources out there. Our docs team, engineering has helped me put together content for this webinar. And so what I'm going to do my best is to hopefully put this all together in kind of a organized approach to help us kind of create a mind map so that we can have more efficient and more performant and more scalable temporal applications today. So what specifically are we going to be talking about today? What we're going to be going into are the different temporal metric sources. Specifically, this includes the cloud observability support. I'll be walking through how to set that up. I'm not going to do a live setup on any of these today because that's kind of tiresome, and our docs are very good on this. But I'm going to be walking through some kind of gotchas and things to keep in mind as you go through. Secondly, there are SDK metrics. So depending on whatever language you're using, you have metrics that are getting emitted out of that SDK. And so I'm going to walk through just some key concerns and things to bear in mind about those metrics. And along the way, we're going to be hitting on some of the metrics that are out there. There's a lot, and I'm not going to be able to hit all of them, but hopefully by the time we're done, I will have explained what some of these critical metrics are so that you can understand how to interpret these. Before we do that, though, we'd need to go through worker fundamentals. All of the metrics are telling us something about what we need to do to our worker potentially. But that doesn't make a lot of sense if we don't even have some kind of foundation to what is a task? What are the different events? What's the life cycle of a task? What are the parts of a worker? How does it work? I'm going to try to give a pretty high level overview of this. I'm not diving into a lot of edge cases or failure states. I'm intentionally kind of glossing over some details to hopefully create a more general observation. And then finally, we're going to go through some key metrics and just kind of look at them and see what they're telling us about our worker. So I think it's important to understand that, you go to production and then things change, or you hit bursts, or, what's happening. And hopefully these metrics can be telling us something that needs to happen inside of either our deployment or our configuration. Now, it's important for me to scope this. So I'm not going to be going into specific observability or APM vendor support. There's a lot out there, and it would be way too much for me to get into. There's also some things about local activities, queries, and so on. There are things in there that I could get into when it comes to workers. I'm intentionally avoiding some concerns around that for the sake of creating a larger mind map to these topics. There's also a matter of rate limiting. You're already probably familiar that workers can do rate limiting. Well, task queues can do rate limiting for you. I'm going to sidestep some of that right now. And then finally, I'm really not going to get into any deployment strategies today. That's also a pretty deep topic, and it depends on your environment. And so I'm going to sidestep some of that. But man, in the future, I would love to dive into that with you. So all that said, what are some of the things that you should probably know before we go into this? Really, you need to have some kind of understanding about temporal application topology. That's what this picture is. You have workers over here, and you have temporal cloud over here, and you're connecting to the cloud. Now, specifically today, what we're going to be focusing on is the worker integration with the task queue over at Temporal, or the task queues, I should say. Okay, so that's what we're going to be zooming in on. I'm not going to get into a lot of design or those kinds of considerations with our application today. So any temporal application that you build, it's integrating a temporal server task queue with the worker that you're building and deploying inside of your environment. Okay, so the observability piece then that we're looking at today is, how do I measure what's going on in that integration? And how do I interpret it so that I can make changes either in deployment or configuration? We'll talk about those in a little bit. Okay, so this is what I think of as like the temporal experience of a developer. You have the circle of life that's happening as you're maintaining this application. So the developer gets to work, starts out with temporal, and you know that you have to create a worker to get going. So in your SDK, you build the worker. And along the way, you have to make some decisions about, well, first, what is the application code? What are the workflow definitions? What are the activities doing? Secondly, you have to be thinking about, how do I configure my worker? Well, for now, maybe I just go with all the default settings. That's common. And then secondly, or thirdly, I should say, how do I deploy this? Am I doing this in Kubernetes? Is it bare metal? What does the configuration even look like? How many workers do I have? These are all the questions that I'm having to make a decision about just to get going on shipping temporal out in the wild. So I check my code in. Maybe there's a CI/CD pipeline, or I just kind of push the binary up to bare metal somewhere, and it's sitting on a machine. And so the worker is now compiled, and it's sitting on the inside of these compute resources. And it's integrating with Temporal via the Temporal client that you've created. Now, from there, you have 3 different sources of metrics getting emitted, okay? From your compute, from your worker, and from Temporal Cloud. Now, all of those are going to be hopefully aggregated and monitored using some kind of visualization tool, maybe Grafana or one of the vendors that are out there. However you're choosing to monitor these metrics, at some point you're going to have to interpret those metrics, and that's going to be telling you things about what to change. Maybe you need to refactor your application code to be more efficient. Maybe you need to change the worker configuration. There are so many different things that you could do there, and we're going to hit on some of those items today. Maybe you need to actually just throw out more workers, maybe spin up more pods in order to take on more work. At the end of the day, what you're doing is you're going to make changes to this, and then you start the whole circle over again, and that completes kind of the circle of life, right? And so you have this temporal experience going on. And this is something that you're going to be doing over time in production, is keeping an eye on your application health. Okay, so I mentioned earlier we have 3 primary, 3 metric sources that we're going to be primarily concerned with in this topic. The first one are your compute metrics. This isn't something we're going to be prescriptive about. How you monitor your compute is up to you. You're going to be looking at your CPU and your memory resource utilization along the way, because the worker sits on your machine. The gold standard is you want to use as much as you can, probably, well, as much as reasonable. So there's cost considerations. There's all these kind of vectors of questions that you're answering about. How do I make my application more efficient within compute? Today, I'm not going to be talking too much about those metrics. Instead, we're going to be talking about SDK metrics. And then those are all being emitted out of the language of your choice. And then there's also temporal cloud metrics. So let's start there. Temporal cloud metrics are really a facility that Temporal Cloud exposes in the web UI for being set up. And for Grafana users, it's really kind of a plug and play experience. Today, the Prometheus endpoint that we expose is actually a Prometheus data point, data source that can be just dropped into Grafana and used out of the gate. It's quite a simple experience. If you're using another vendor for observability, then here there be dragons. There are some scripts that we do have in our that have been contributed by community and even ourselves to try to help other users of other vendors be able to pipe these cloud metrics into their own platform. I'm not going to get into that too much today, just because there are some challenges with that would be pretty deep and also, frankly, over my head. So I'm not going to go there, but I will tell you that on the horizon, cloud, we are working to expand our coverage of this more and make it easier for folks that are going to be using other vendors. So how do you get set up with your cloud metrics? It's pretty straightforward, and we do have good docs on this, but I thought it would be useful to just kind of do a 3 or 4 step process to walk through. How do I get this thing going? Now, a prerequisite to this is that you are a global admin. This is set up by the global admin on your account. So if you don't see the settings icon that's over here on the left that would allow you to go into this integrations point, then it might be because of your role, and you need to ask your global admin to work with you on getting this endpoint set up. So that's what we're doing here, is we're going to go to the integrations page, and you can append your certificate into that text area. Some people ask about, do I have to have only one certificate in there? Actually, you can append or concatenate certificates inside of the text area that's there. And yes, you can use the same cert as you're using, like in a namespace. Maybe you're only passing in a root certificate to get this set up. That's fine if you choose to do that, and you want to just use identity certs to discriminate connections. That's fine. Finally, you just save, and then you'll note the endpoint URL, and that is the data source endpoint that we're going to be using for when we get into Grafana. So this is all Grafana set up here. And basically, all you're going to be doing is creating a new data source that points to that endpoint. And I also need to pass in my certificate details here. Okay, so I'm going to be passing in the cert and also the key since it's connecting via MTLS. So you'll use this endpoint and then go ahead and save the data source. It'll test it for you at that point. And what do I look at? Well, we have a dashboard that's community maintained out there for cloud metrics. And so you can go out and snag the JSON, however you want to import the dashboard into your setup. It's up to you. At the end of the day, you're uploading this JSON into Grafana as a dashboard to be exposed. And then once you've loaded it, you can go into the dashboard, select that new data source, however, whatever you named that data source, and you should start seeing your metrics appear. Okay, so like I said, I'm just going to walk through how to get started on this, and please reference the documentation for specifics on doing all this. So that's cloud metrics. SDK metrics to get set up. There's some we have really good documentation on getting this set up. We also have samples repos for each of our SDKs that show pictures or show illustrate how to wire up the metrics in your SDK. But I just wanted to call out some important things about the SDK metrics. One is most of the answers for how you tune your workers, they're going to come from these metrics. So even if you can't get the cloud metrics going, really the majority of your intelligence is going to be coming from the SDK metrics anyhow. If you're coming from open source over to cloud, then you probably have all this already wired up. Just check the dev guide, and like I said, it'll show you how to configure the metric scopes, and then those are put onto the Temporal client. There are a couple of things that I've noticed too as I've gone through and set these up in different SDKs. Bucket configurations. There are some metrics that are going to be, for example, observing latencies that exceed something like 10 seconds. So you're going to be sure that your buckets are configured correctly. If metrics look a little bit off to you, then take a look at your buckets and make sure those are configured correctly. And we do have a community dashboard that's out there that's a good starting point. There's additional metrics, though, and queries that you're going to want to get into. This isn't a Prometheus masterclass today, so I'm not going to get into all the queries, but that would be a good follow-up session as well. Please reach out to me on community Slack if you want more details about concrete queries to be using in addition to the dashboard. And then finally, we're connecting over gRPC. This is a network thing. So be sure that you're monitoring the usual networking suspects in those metrics, like the request failures, request latencies, long request failures. We'll talk about what long request and request is in just a little bit, but be sure you're watching those. At the end of the day, though, just please have SDK metrics configured, set up, have a dashboard, or at least access to those metrics so that we can help you. It really helps us if you have some understanding or at least have access to the metrics so that we can help you add on our dev success channels in the community. Okay, so that's the setup of metrics. Let's move on into some of the fundamentals of what is it that we're even tuning? What is it that's indicating it needs to be tuned? In order to answer these things, we have to start kind of all the way to the beginning. Now, I'm not going to go super deep on this. There are two phenomenal webinars that have already been done by Tiho, one of our dev success principal here, who has done some extraordinary work on these event histories. I really urge you to watch those webinars to understand what's happening on the task queue. But for our purposes, we need to do a high-level look at it. So let's just think of a task as having a life cycle. It's scheduled, there's started, this is an event, and then the task is completed. Okay, so the task goes through these stages or these states, and that's what our worker is going to be impacted by when we talk about tuning. Which part of the worker configuration are we going to be touching along the way? So the way I think about this is you're passing in a task queue into your worker, as you know. That task queue is actually kind of an abstraction over two independent task queues. You have a workflow task queue and you have an activity task queue on Temporal Cloud. So whenever you're polling for these tasks, which we'll get into in a little while, you're actually polling one of these task queues. That abstraction then kind of emerges in our life cycle for a task as well. You have a task queue or a task that has been scheduled. Your worker is going to pick it up. It starts the work, and then it's going to notify that it's been completed. So some examples of this are like when you start a workflow, it's going to schedule a task, a workflow task, though. And it's going to start that task on your worker, and then it's going to be notified about completion after the fact. In the same way, you have activity tasks that are independent. They're also really segregated. So an example of that is execute activity, right? So we're going to schedule the activity, it starts, and then it completes. It's pretty straightforward, but it helps us to kind of map this to the different stages of what a worker is going through in order to pick up those tasks in that integration. So that takes us into worker fundamentals. We've established kind of from a very high level and maybe an overly simplistic view of task events or states. Let's try and map that to how a worker thinks. So a worker is really composed of three primary parts, and that is the polar. I'm going to call them an executor because it's in some of the SDKs that way. It's really a task handler. It's the thing that's doing the work. And then finally, you have a worker cache, and we're going to talk about each of these independently. So in order to do that, though, I'd like to start on the doer, the actual thing that's doing the work, the task handler, the executor. So a task executor then is something that's going to ultimately process the task and execute the code inside of your worker process. Okay. So you're writing your code, your activity code, or your workflow definition. This is the thing that's actually executing that. Now, where did it come from? It came from a polar, and it received it from the task queue that was at Temporal Cloud. We'll talk about the details of that in just a moment. But if we were to put kind of a "you are here" on the map, hopefully this executor kind of shows you where we are in the cycle of a task. So it's been scheduled previously, and now it's been started. And the executor is going to do that work. So I think it's helpful to map this to your worker configuration. This is an example of your Java SDK configuration. And what I've done is I've set all defaults into this configuration just to hopefully organize and illustrate which aspects of the configuration impacts this executor. So you see that we have three properties here that we can set: the max concurrent activity, execution size, concurrent workflow task execution size, concurrent local activity execution size. Try and sing that. Yeah, I can't. Those are by default in Java set at 200. It's quite a bit. Every SDK has its own defaults for a lot of reasons. But these are the three primary properties that you're going to be touching whenever you want to, for example, increase your utilization or the number of concurrent executors that can handle tasks concurrently. It's a mouthful. How do I know when I want to do that? How do I know when I need to do that? Well, the first metric that we come across here is worker task slots available. This is an SDK metric. And really, there's no reason why this should be at 0. If it's at 0, there's some problems with that. One, you're not going to be asking for any more work from the task queue. It's an indicator that either your compute resources are not enough. Maybe you're actually pinned out on your machine that you're hosting your worker on, or possibly your configuration is too conservative and you need to actually increase the sizing on these executions. So that's a first metric to kind of keep an eye on. And if it's hovering down around 0, let's measure that with the compute resources. I'll address that some more later on. So real quickly, let's talk about the two different types of tasks that are actually getting executed. An activity task is pretty straightforward. It's going to execute the registered activity code, and then whenever the activity is completed, it'll notify Temporal Cloud that the activity is completed. An interesting metric there is the task execution latency. That can give you an idea on maybe you have some inefficient programming going on inside of these activities, and you need to revisit that. Maybe that's if it's taking up too much time, there's an opportunity for a refactor going on there. The real interesting one is the workflow task executor. The reason this is interesting is because the default workflow task timeout is 10 seconds. And so what I'd like to do is just walk through the different steps of what takes place when you have received a workflow task, and can we do this within 10 seconds? So first, what's going to happen is it's going to fetch a workflow execution to handle this workflow task that it just received. First, it's going to check in the local cache to see if the execution exists. And if it doesn't, it's actually going to have to accumulate that and get the history. And it's a paginated API that it's connecting to. So there's some network tax there during this first part of the execution. The second thing it's going to have to do is it's going to pass the history through your data converter if you have any set up. Not everyone uses a data converter, but if you do, this is another potential bottleneck where if you have some inefficient deserialization going on, well, time's a ticking. You got 10 seconds. So be sure that that your history is not huge. And then secondly, be sure that your data converter is efficient. Okay, so thirdly, we're going to execute the workflow definition up to what we call an awaitable. An awaitable is just anything like a timer, some kind of blocking call to an activity, and so on. And then if that's been basically blocked at that point, then it can notify Temporal Cloud that the task has completed, and it's going to enclose any kind of commands that need to get scheduled for example, like an activity task might need to get scheduled because of your workflow definition saying, this is what's next. This is how I progress. So what SDK metrics can I look at in order to see if I have where the bottleneck might be if I have something like workflow task timed out? If you're seeing that event appear in your UI while you're looking at your history, then you might want to take a look at the workflow task replay latency. This is a pretty good indicator that your history is pretty large. Remember that Temporal likes to scale horizontally, not deeply, with a lot of events. So if you have very large histories that you're sending over the wire and then replaying, then that might be what's causing some kind of bottleneck. And then the workflow task execution latency is just going to give you an idea on whether your tasks are taking longer and longer to complete. Okay, so those are the two different types of executors and some of the metrics that relate directly to the different facets of the executor, depending on whether it's a workflow or an activity task executor. So secondly, I'd like to go through a cache. The local cache is on your worker inside of the process. It's shared among workers. And so this is a pretty deep topic as well. I'm not going to get too deeply into how a sticky queue works with Temporal Cloud, but I'd like to get into that another time. For our purposes today, let's just trust that a workflow execution is getting stored locally in order to improve our performance. So that's all it is. It's an in-memory cache of workflow executions. So whenever the configuration says size, it's the maximum count of the workflow executions that will be stored there. Okay. Why would we store workflow executions? Well, it creates an affinity between the server and your worker. And that affinity allows us to not have to continually be sending a workflow history, a big blob, over the wire back and forth. So there's quite a bit of speed up that we get as a result of this. And where are we on the map? Well, the workflow task, assuming that it has been completed successfully, it's going to go ahead and just exist here in our cache. The workflow execution is stored there. What are the parts of the configuration that will impact this? This is, again, another example from Java. I chose Java just because it has, beyond the other SDKs, it has some peculiarities, or not peculiarities, but some other ways of thinking about how do you store workflow executions. And so you can see over here on the left that you can set a cache size, or you can set the thread count. You can set both, but it probably doesn't make a lot of sense to do that. For the worker configuration that's being actually kind of a part of this worker factory, you can actually set the scheduled to start timeout. This is more telling the server that has kept um, a identified sticky queue on the server for kind of storing all of those tasks for this worker. It's going to tell it that, hey, I only want you to keep this sticky queue alive if I've gotten some pull requests for new tasks within 5 seconds by default here. If it hasn't heard back from the worker in 5 seconds, then it's actually going to transfer that over to the non-sticky queue so that another worker can pick up that task. Like I said earlier, that's a pretty deep topic. I'm not going to get too much into that. I just wanted to point out the configuration option does affect your caching there. Now, the Java SDK, like I said earlier, has some alternatives in terms of how do you keep workflow executors around to get this optimization. So you can set the thread count. I see most Java developers doing that. You can set the cache size directly as well. And what that'll do is it'll keep the execution threads around. And there we go. Kind of slow. Now, if the worker crashes, like I said earlier, the non-sticky queue will go ahead and pick that task up from the sticky queue on the server so that another worker can pick it up. Okay, so what are some metrics that I can use in order to monitor what my cache is doing? We have a couple of metrics here. One is pretty specific for the Java SDK. So the sticky cache size is something that you can keep an eye on. And this really relates to how your configuration is set up. You really do want this value to be obviously below the cache size. If the workflow executions start to get swapped out because of the cache, then it's just going to decrease the efficiency because whenever a task is received from Temporal Cloud, it wants to execute it. And if there is nothing in the cache, well, it's going to go ahead and say, okay, well, I'm going to swap out a workflow and then I'm going to put this new one in there. So that swapping can be expensive. That's why you would potentially want to watch this metric as well, the sticky cache total forced eviction count. This should be pretty stable. It should be pretty low. If it's increasing, then that's a pretty good indicator that you're thrashing the cache. And so you should probably increase your cache if your compute resources can handle it. If they can't, then we need to figure out what we're going to do about that. Okay. So we've talked about the executor, we've talked about the cache. Now let's talk about the poller. So a worker poller is going to be simply requesting either workflow or an activity task in order to pass over to the executor based on the type for processing. It's that simple. But how does it do it? Well, what it's going to do is it's going to say, do I have any execution slots available? An execution slot is simply saying, hey, I can do work. If the answer is 0 when it asks, it's not going to make a pull request. And so if you're seeing that you have a task log or a task backlog increasing temporal, well, it might be because you're not processing work fast enough, and you might need to increase your executors. I'll talk about that in just a moment. For right now, though, we just need to see that that could be a blocker to it creating this long polling request to Temporal Cloud. Now, that long poll request is going to be around, by default, 60 seconds. Okay, so it opens this connection. It's going to actually it creates a request, for 60 seconds. And if it times out, it's going to get an empty response. And then what it's going to do, it's going to try again. Okay, so where are we in the task lifecycle? Well, here we are. We scheduled the task on the task queue at the server, and now on the worker, we're going to start it. So the poller is the thing that grabbed it from the task queue, and now it's going to start it in your process. What part of the configuration is impacting this? Well, we have two different options here. You can set the activity task polars and the workflow task polars. Pretty straightforward. These are, but the default, again, for Java here is 5. Typically, I'll talk about a principle here about polar counts, but this is what you can use in order to increase or decrease the number of polars that are connected to Temporal Cloud in order to get tasks off of the task queue. So what are some metrics that would be interesting to watch for this? Again, we have an SDK metric called num polars. That's not a num polar. It's the count of the polars. That value should be hovering around the sum of the workflow and activity task polars, and drops in this value. It could mean that maybe your workers are crashing. It could mean that you need to increase the execution size configuration that I pointed out earlier, because what it's saying is, hey, maybe I have an inadequate number of polars trying to connect to the server. And so you would keep an eye on that worker slots available metric that I pointed out earlier and reconcile that with this metric here. Now, there is a cloud metric here that you can use that is really interesting for monitoring whether you're going to be able to handle sudden changes in traffic. Maybe you have some kind of bursty application, and you need to, the general rule of thumb, I'm going to steal this quote, is that you always want to have a polar around maintaining a long connection, the long request, to Temporal Cloud. If you're seeing that your polars are dropping off, or in other words, that you have 0% of the number of polars that are connecting, then it probably means that you're not ready to receive the work that Temporal is ready to give you. So try to keep decide what that number is. It could be 5-10% of the total number of task polars around. But the point is to have a polar at the ready to receive a task. And then finally, there's this metric called long request latency, which is just measuring the amount of time that a request is taking to connect to Temporal Cloud. You might think that a high latency number is a bad thing, but in this case, it's actually a good thing because it's a long poll. Long request is the long poll, and what this is specifically the poll task queue, poll workflow task queue, and poll activity task queue requests that are coming out of your SDK. And so you want to keep this thing up around 60 seconds. If it's really getting a lot lower, then it might indicate that you don't have enough polars to take on the work. Or like I said earlier, it might mean that you need to increase your execution size so that they can be around. So just out of curiosity, I was curious, what is the default settings for this? So depending on the SDK you're using, this is a breakdown of the default polars. I was curious about this because really the guidance that we give you is, how many concurrent polars do I need? Well, don't just go increasing polar counts arbitrarily. If you think that you have a task backlog, and I'll get into some of the metrics that might indicate that in a moment, then don't just start increasing the polar size. Instead, you should really be taking a look at, am I actually doing the work that it's handing that the polar is actually handing to the executors. So look at your execution size, or maybe even your cache size. You might have a lot of thrashing going on there. So there's some inefficiency going on in your worker process. At the end of the day, though, you can increase the polar counts, of course. That's your configuration. But be conservative about when you do that and really understand why you're doing that. Maybe there's some latency between the worker and Temporal Cloud. And so you need to just increase the polars to keep on grabbing work. This is another link and kind of a call out to this worker performance dev guide that we have out on the docs there. There's some great details in there. I strongly encourage you, even if you're just getting started with Temporal, go out and read that guide. It's maybe the most important document we have in our docs. Okay, kind of slow here. There we go. All right, so we've gone through some worker fundamentals. Now let's jump into a few key metrics and some scenarios on some questions that we might be asking with some very, very important metrics that you should be watching. These are the scheduled to start latency, the poll success or poll success sync, what we call a sync match metric, and then just general service latency. How do I know, that Temporal itself is even performing? So whenever we look at these metrics, we want to answer some questions, right? If we're seeing maybe our performance in our application slow down, well, inquiring minds are going to want to know why, and so we're going to be asking some key questions. Do I have a backlog of tasks? What are some metrics that are indicating that? If I do, who's causing the backlog? Is it Temporal Cloud or is it my worker fleet? Why are my compute resources underutilized? We talked to a fair number of folks that are scaling out their pods quite a bit, but they aren't even using the resources that those workers are being hosted on to begin with. Maybe there's some configuration opportunities there to use more of that machine and save some money. Should I deploy more workers? When should I deploy more workers? Maybe I don't want to make a configuration change because I don't want to have to do a redeploy. I just want to scale out the workers. These are all kinds of questions that can be answered with some of these metrics that are coming up. So very important metric here, schedule to start latency. There are two different variants of these. There's workflow scheduled to start latency and activity scheduled to start latency. By now, hopefully I've separated the workflow and the activity task in your mind. And I've also separated that how those are getting executed on your worker. So hopefully this makes some sense to you now. The question is my worker keeping up? Okay. There isn't really a great number that we can just give out for always keep this value beneath this latency number. But in general, try and keep it under, a second, 3/4 second, in order to see if there's some kind of bottlenecks or potential for a task backlog. Remember that the perfect state that we're aiming for is zero latency between the time of, Temporal picking up a task and then you actually executing the work. That's kind of what our gold standard is that we're trying to work towards. Obviously, we'll never completely get there, but that's what we're aiming towards. Or if we're going to have a task backlog, well, we need to know whether we're going to be able to pay it down later on. The schedule to start latency can help communicate whether we have a backlog. So for me, it's helpful to think about this in a couple of different ways. First, from the worker perspective, do I have the schedule, the started and the completed task lifecycle? And then from the task queue perspective, you have it's been enqueued onto the task queue on the server, and then it's been dequeued. Okay, so the polar sits right in the middle of that. And so when we talk about schedule to start latency, it's actually the time that that task was written in and scheduled on the server to the time that it was dequeued and pulled over and started on your worker. Okay, so if that latency is increasing, that means that you're not pulling off work fast enough, probably off of the task queue. So another way of confirming this or to see if this is happening is what we call a sync match rate. Again, it's asking the question, do I have a backlog? You might if the poll success sync cloud metric is less than the poll success metric. So this is the Temporal Cloud poll success metric here, and then you can divide this value by the poll success sync. Well, what does that even mean? Well, whenever we talk about poll success sync, what that metric is saying is that I didn't have to write it down to the database to send the task over to the worker. In other words, when the schedule came in or when the task came in, I was able to deliver it right away to the worker. Now, the poll success metric on the left is actually saying, well, I actually had to write it down. Or actually, it's just saying that the poll was successful, excuse me. If I'm actually seeing a decline in this, then I'm going to have a low sync match rate. Okay, usually what I want to have is all of my tasks sent to the workers directly. I don't want to have to write it down in persistence because that's going to be up to like a 200 millisecond additional tax that you pay on that task being delivered over to your worker. But the sync match rate, if I can keep this hovering around, above 95% consistently, then I'm healthy. So this is a way for the server to actually track on whether you might have a task backlog building up. So there's two different approaches to determining, whether I'm pulling off work fast enough. And finally, I have to ask the question, is the problem due to Temporal Cloud, or is it my worker fleet? Well, we will keep our service latencies down, typically anywhere from 50 milliseconds to 200 milliseconds. If you're seeing these operations, the start workflow execution, signal workflow execution, basically the user experience types of operations that go on with our API, if you're seeing these increase above 200 milliseconds, then it could very well be that Temporal Cloud itself is having an issue. And so one thing you can be watching is the service latency bucket metric. It's a cloud metric again. And you can see here we have a pretty healthy representation where Temporal Cloud is typically serving up anywhere from 20 to 50 milliseconds on getting the operations started and completed. And then rarely do we have around 100 milliseconds. So if I were to look at this graph, I would say Temporal Cloud is performing just fine. This is what we would expect. Okay, so I'm going to just kind of fly through this bit. The other question that we would want to be asking is, do I have underutilized compute resources? Can I use more on the machine that or the host that my worker is even running on? And like I alluded to earlier, first, what I would do is take a look at your worker task slots available metric and be sure that that's not consistently getting dropped down to zero. It's possible that if you do have more resources available based on your metrics on your compute, then you can increase those to use more of the resources there. Secondly, you might want to consider increasing the cache size or the active thread count if you're using the Java SDK in order to keep more around for these executions. So that'll make your application more performant, and it'll also use up, of course, more of your compute resources. Okay, that's a whole lot. I know that I went a little bit longer than I planned on for just the lecture part. This is a list of some critical resources that are out there for you to get familiar with on getting set up with the metrics, interpreting the metrics. We have a really lively community group as well where you can go in and ask any of these questions. And so I think that's what we're going to do now is start to take some questions, and I'm going to do my best to answer them. If I don't know something, I'll tell you, and I'll research it and get back to you on it. So what kind of questions do we have? Let me see. Okay. Open. Does Temporal Cluster emit similar metrics if I'm not currently on cloud? Yes. The Temporal server, I didn't include the link here in our resources. I'm going to go back to this in case y'all want to write it down. Yes, there's actually a much richer set of metrics. And by the way, even our cloud observability endpoint, we're planning on exposing even more of those metrics to y'all as well. What is stored in the worker cache? Okay, so that's actually that's great because I got a lot of clarity on that recently. So it is actually the workflow execution. It's the workflow object itself being stored in the cache. Okay, so it's not just a blob of the history, which is what I always thought, but it's actually the worker object itself. So obviously that's memory intensive. So be sure that your compute can handle the cache size that you pass in your configuration. What happens if you introduce a sleep of 1 month between activities in a workflow? How is the state maintained then? Okay, that's not directly tied to observability, but I can answer it real quickly. That's basically a timer is written down in persistence, just like any other kind of command. And then after 1 month, it'll actually get fired, and you'll pick that up as a task to cause the workflow to make progress at that point. Would you suggest using sync poll match percent to assess if there's enough polars? Yeah, you can. Remember though, I always get a little bit nervous when people say enough polars, just because it could indicate that you need more executors as well. Okay, so don't just go increasing the number of polars. See if you can't utilize more of these executors, and check the efficiency of what's going on before you just dial up the number of polars. And please keep the polar count quite a bit lower than your execution size. There's some caveats to these rules based on maybe the type of work that you're doing inside of the activities. If you're doing some maybe real heavy file operations or something, there are different rules based on whether you're doing IO or CPU intensive operations. So there's not like a strict rule that I can come up with on this. But yes, the sync match rate is very useful for at least determining if you have a backlog. What's the reason for the difference in the polar configurations between the different language SDKs? Probably a whole mix of historical reasons. If you're talking about just names, that's probably due to just history. It could also be due, though, just how the language works. Go routines are much lighter weight than threads. So you can't even set thread counts in Golang, for example. The model that we even execute in our TypeScript SDK is quite a bit different than like the Golang SDK. So part of this is just the nature of the language itself. And so the configuration is written to, to be correct for the language. So that's why there's some variance there. Hopefully, though, they're close enough where these principles that I went through today should be adequate to at least give you some comfort on moving from language to language and on knowing how to configure them. Is there a good way to tell when throughput may be limited by task queue level activities per second rate limit configuration? Yeah, so like I said, I wasn't going to get into rate limiting concerns too much today, but if you see an increase in your schedule to start latency, and you're doing rate limiting on the task queue, for those who don't know, you can actually set up your task queue configuration or even just the worker configuration to throttle activity executions per second. That's really useful for maybe you have a rate limiting on a third party API that you're connecting to, and Temporal can actually do the work. It can actually throttle for you. You don't have to build that rate limiting logic yourself, which is pretty handy. But that also means that you're going to have an increase in your schedule to start latency because obviously the work is getting throttled. So that's, I don't know if I answered that question directly, but for short-lived workflows, what would you look for to understand STSL? I don't know what STSL is. STSL. Scheduled to start latency. Okay, we're doing cool abbreviations now. For short-lived workflows, what would you look for to understand scheduled to start latency increases, since the executions tend to not be concurrent? I actually don't even understand why they wouldn't be concurrent. You're concurrently pulling tasks off of the task queue, and if they're short-lived, they are going to be executed concurrently. So I don't fully understand that question. Maybe you can follow up in the community with me about that. What metrics do you use, or what metrics do you best use to auto scale your worker fleet? Yeah, I knew this was going to come up. So that can be a mix of your compute metrics, of course. The schedule to start latency is obviously something that you're going to keep an eye on. The sync match rate is something that you can be using. There's it kind of depends on what your resources are doing, and when you need to auto scale those. It's possible that you just need to be looking at your configuration though too, instead of just always scaling up the number of workers. Maybe you need to actually take a harder look at your configuration and be sure that you're being efficient with that first. That's a pretty deep topic. Please reach out to me on community and we can get more into auto scaling there. I think that's pretty close to time, Alana. So these are some great questions. I'd love to keep going on them, but
Yeah, thanks so much for the great presentation. I really appreciate it. As Mike had mentioned before, please feel free to reach out on our community Slack. Again, you can scan the QR code to get to our community page. And we hope to see you at Replay in Seattle this September. Thanks everyone for joining. I hope you found this information valuable. Have a great day.